It's not a game, it's a rich thing.
Oh, look who came crawling back to me for another Blender tutorial. You're addicted, aren't you? You need to inject yourself with a Blender tutorial every day to keep yourself alive. You're just completely hooked onto stuff. Well, don't worry, I will give you your daily fix, because today we are going to be talking about particle nodes. This is a feature that has been promised for a very long time and it's still in the works, and the basic idea is in the same way that the shader editor uses nodes to create the material, so it's node-based. Very soon, particles are going to be replaced with a node-based system as well, and this is going to be rolled around in the future versions, but right now we're using the 2.91 alpha to access these features. So it's probably a good idea to adapt before we get left behind. We'd need to learn node-based before, it's the only option. So let me be your shepherd, let me be your guide, and we're just going to get through it very quickly. I want you to open up Blender. Duh. If you didn't open up Blender, you're probably not smart enough for this tutorial. Either way, again, 2.91 alpha. This is only in the newer Blender versions. You're not going to find it in the older ones. Once you have the alpha or whatever, what I want you to do is go to Edit, Preferences, and then in Interface, you're going to see Developers Extras is disabled. This is because they don't want you wielding this power. Particle nodes is only for highly trained specialists like ourselves, so to enable them, because right now they're not enabled, you're going to need to enable Developers Extra, go to Experimental, and by the way, Experimental is not enabled if you don't have Developers Extra, so go to Experimental and enable the new particle system. Once you do this, you are going to see a new editor type. So if we go here, you're going to see something called the Simulation Editor, which is basically like the shader editor, but it's nodes specific to particles. So how do we set this up? How do we make a particle system? Well, long story short, we are going to split the window so that we have both the 3D viewport and the simulation editor. And just like in the material editor, you need to create your material or node tree is probably the better way to think about it. So we are going to create a node tree. This is where our simulation is going to live. And then you're probably thinking, how do I apply, whatever nodes I put here, particle, output, whatever. How do I apply these nodes to my object? Well, it's not that simple. So what I'm going to do is I'm going to add in also a new object type you might have not known existed. So Shift A, and you're going to see something called point cloud. This has nothing to do with photogrammetry and like having a bunch of vertices for your point cloud. This is literally just particle point cloud. So once you add in the point cloud object, what you need to do is go to the modifiers. You're going to add in a simulation modifier. If you don't do these steps, it's not going to work. Add in your simulation modifier. We then need to say, okay, this object is using this modifier, but which simulation node tree is it using? Well, we wanted to use this one, so I'm just going to select that one. It's going to be the only one available. And then for the data path being, where are we outputting these particles? And in fact, this is the node for that. So Shift A, output, particle simulation. You could have multiple of these. Specifically, we want this one, so I'm just going to Control C, Control V. So now, it disappears, which basically means it's ready. And long story short, we have created a simulation tree right now with nothing in it except for the output node. And we've created the particle point cloud object, which is going to inherit all the stuff that we do here. Okay, so now the question is, how do these nodes work? How do we get a basic particle system going? Well, you're going to see that this particle simulation, this is kind of like the material output node. This is the final destination, the final node. We want to plug in emitters into here. This is where the particles come from. We want to plug in events. This is what the particles do. And we want to plug in forces. And this is the forces. It's the, I don't know a synonym for forces, but it's the effects in some sense that drive the motion of our particles. So this would be gravity. This would be like having a cube emit the particles. And this would be like change the size of the particles or have them explode or something. Okay, so first of all, for particles, we need a emitter. So Shift A, and you're thinking, where are the emitters? Think about it. Oh, there it is. There it is. It's in the emitters. And you're going to notice that a lot of these nodes have the word mockup, which basically means, they exist, but they don't really do anything. And a lot of these menus have quite a bit of mockups. So we really have no choice except particle mesh emitter, because the other one is a mockup. So yellow goes into yellow. So we've added a emitter type. And for the emitter object, what is going to be shedding the particles, we could just add in a Suzanne and make that the particle thing. And you can see if we hit play, particles come out of it. So far, we don't really have much control over how this happens. Like, it just kind of goes out everywhere. Maybe we want this coming from the surface or the volume, or just kind of like coming out with a different velocity. Right now, we can't control that. but it is being emitted from the mesh. And you're going to see some, very obvious stuff that you could play around with, like the rate. If we bring this down to 1, it's going to be shedding particles very infrequently. And as we make this bigger, it's going to be more and more particles. And this point cloud thing is kind of like the bounding box for our particles. And the whole idea of particle nodes, by the way, is it's procedural, fine, but it should also be running significantly. And I mean, listen to me, significantly faster than the old particle system. So we might even be able to see some of that here. So we can just change the rate of this to something crazy, even like 5,000. And that's shedding a bunch of particles, but I'm still doing this real time and everything's fine. Okay? Now, one thing that is kind of a new idea, it doesn't exist in the shader editor or in animation nodes or anywhere else. This is a new idea, so I need you to get used to this. It's not necessarily one branch goes to one, I don't know what to call this, like input. You can actually have multiple nodes going to the same input. So I'm going to duplicate my mesh emitter. I'm going to duplicate my object as well so that we have 2 monkeys. So this mesh emitter is going to be for Suzanne number 1. And the second mesh emitter is going to be for Suzanne number 2. So you can see this is Suzanne 001. And I'm going to plug both of these into the emitter. So this is not a thing that's normal for Blender, having 2 branches going to the same input of the same node, but it is here, and you can actually add a bunch of different emitters. So now we have 2 emitters that are kind of independent of each other. Like we can have one outputting at a rate of like 4,000. So this one has a very dense output and this one only has 100. And they're completely independent from each other and it's procedural and it's great. So key idea, multiple branches to the same input. So we have our emitters. What about events? Again, this is what the particles do. Well, for an event, we just Shift A, we look at our events. We see that this one is a mock-up, so we'll just go for particle birth event. In other words, this is an event that's going to happen when the particle is spawned. So it's going to happen immediately when the particle is made. So it's kind of like a property of it. So I'm going to connect the event. And then it's basically saying, okay, whatever I'm going to plug in, whatever I'm going to execute is going to happen exactly when the particle is made. Well, what do I want to execute? We'll go to your executables, and you're going to see we can do something like set particle attribute. Set particle attribute is a very kind of weird node. It's kind of like vertex color or the attribute node, more is a better analogy for that. I don't know what I was thinking with vertex color. Attribute node in the shader editor is very similar to this, where you can type in your attribute data paths and actually extract that data. So for example, and this is a example I've seen in another tutorial, so I'm just going to use it. Whatever, it's mine now. We can change the radius, in other words, the size of the particle, which is a float, meaning it's a number. It's not a vector or color, it's just a number, it's the radius. So I can control the radius and have that be our executable, which is now gonna, when the particle is spawned, in other words, all the particles are gonna have this radius, which we can change procedurally, but we don't want it to be too big. So I'm gonna set it to like 0.1 and reset the simulation. There we go. So you can see we can make new particles be bigger, and something I really wanna emphasize is if I change this right now, right in the middle, it's only gonna affect newly spawned particles, because it's an event that happens on birth. So particles that have already been emitted and are already traveling, not going to be affected. And again, because this is a procedural approach, there's no reason why you cannot animate this. So let's have it start at 0, keyframe, go up to 60, let's have it go to 1, keyframe, and let's play this. So you can see the particles that are being spawned get bigger and bigger and bigger. It doesn't change the size of the particles that already exist, but it changes the spawn properties. And you can see that's pretty cool already. And of course, we can, just like the previous thing, we can have multiple events go into the same thing. I'm not going to talk about many other events because right now there just aren't many, and the ones that do exist are mock-ups. So finally, let's talk about forces. And let me actually just delete these keyframes and keep it at a nice 0.1, clear keyframes. Okay, so this is what we have right now. We can have forces, which again affect the motion and how these particles interact in terms of physics. So let's add in our forces, Shift A. Forces, well, it seems like we only have one option, so let's use it. A force is something that you plug in here, so blue goes to blue, magenta to magenta. These are kind of like printer colors, actually. It's a cyan, magenta, yellow. That's interesting. Either way, a force is basically like something like gravity or wind or vortex. And if we take our Z component, the up and down, and set it to like, I don't know, -1, it's going to start reacting like gravity. So negative 9.8 for you physics nerds. That's the proper gravity number, depending on your, scene size and all that. But don't worry about it. So we can have a force that we can have it go sideways on the x-axis or the y-axis, whatever. And all of this is procedural. At any point, we could change the size of this or change which emitters we want. So maybe we don't want the second Suzanne emitting anything. So now we only have one Suzanne emitting, and it'd probably be easier to see if I make that less intense. So now this Suzanne isn't emitting anything, but if we add in our second Suzanne, put that as an emitter, now they are both doing it. Something interesting you can do with the forces is you don't have to have it just be a vector, but you could have the vector driven by a object. So I'm gonna delete the second Suzanne as our emitter, and for our vector, our force vector, this set of 3 numbers, what we can do is we can use something called, and I'm gonna need to remember where this is, so just give me a second. It's object transforms. Basically, this takes a object like our second Suzanne and it outputs its location. If we put this in here, that basically means that the force is going to be determined by the location of our object, which means it's going to look like it's, think about it, attracted to the monkey. We move it, it's going to be moving with it. So, that's kind of a neat idea. Or you could have multiple objects, like a second Suzanne. We add in this other one as the transform. And we could do a bit of vector math, something like adding these together, and maybe also, adding them together is pretty good. It's almost like an average, so it's going to go somewhere in between them, kind of, so they both have influence. If I move this very to the left, it's going to have influence. If I move this very down, it's going to have influence. But yeah, these are kind of the key ideas. We could mess with a lot more. Truth is, we don't have a lot of nodes right now, so maybe it's not worth it. But hopefully you will understand these ideas about emitters, events, and forces, and that this is a broken thing right now. In fact, this crashes quite a bit, and we are lucky that it hasn't crashed during this tutorial. Anyways, this is the birth, pun intended, particle birth. This is the birth of particle nodes. I'm excited to see the future of it. Maybe next update, we're going to get a bunch of more working nodes, and we can do a bunch of cool stuff with texture splatter, and I don't know. Hopefully you enjoyed this crash course. If you did, the best way to support this channel and CG Matter, Default Cube and CG Matter, is via the Patreon. Patreon is a way to keep these channels afloat. Also, it is a way to get something in return. You can get behind the scenes access, Discord access, exclusive tutorials. That's kind of like the big one. You could get tutorials that are not available for free. That's the good one. And there's also project files, so the blend files I use for different stuff. But it's also a great way to support this fucking channel. So, if you enjoyed, I'm glad that you did. People that want to be patrons, thank you. I appreciate it. It's very nice that you chose to do that, although you are getting something in return. Link in the description if you're interested. Try to keep these things at the end. Yeah, that's the show. I'm done.